So the next section is solving multi-step inequalities, which in your textbook is section 2.4. So we're going to solve and graph these 5 inequalities. They're all multi-step, but the cool thing about inequalities is that you solve them pretty much in the same way that you solve equations. So lots of the things that we do to solve equations will carry over to inequalities. So for number 1, it's x over -2 plus 4 is greater than -1. And we want to get x by itself. We want to solve the inequality for x. So we need to move everything away from the x. So the first thing that we can move away is this plus 4. We can undo this addition. So to undo adding 4, I can subtract 4 from both sides. So I'm going to bring down the x over -2. And then 4 minus 4, those cancel out. I didn't multiply or divide by a negative yet. I just subtracted a number, so I don't need to flip the inequality symbol. And then -1 minus 4 is -5. And then now I have x divided by -2 is greater than -5, so to undo dividing by -2, I need to multiply both sides by -2. So multiplying by -2 and dividing by -2, those undo each other. And then I'm just left with x. I multiplied by a negative number, so I need to flip my inequality symbol. So it goes from pointing to the right, it'll now need to point to the left. And then -5 times -2 is positive 10, since a negative times a negative is a positive. And then for our graph, for number 1, 10 goes in the middle of my number line, and then I need to go up to 11, and then 12, down to 9, and then down to 8. And then my inequality is x is less than 10, so it's just less than, so I need an open circle. If it's just less than or greater than, it's an open circle. If it's less than or equal to or greater than or equal to, it's a closed dot. And then x can be any number less than 10, so that has to point to the left, because as we go to the left on the number line, the numbers get smaller and smaller. And then also the point on my arrow matches the point on my inequality, so they're both going to the left. And then for number 2, 3x minus 2 is less than or equal to -11. So same thing, I'm solving for x. I want to get x by itself. The first thing that I can do is I can undo that -2, the subtraction, by adding 2 to both sides. So -2 and +2, those undo each other. I'm going to bring down the 3x. Bring down my inequality symbol, just make sure it stays pointing the same direction. And then -11 plus 2. So I think I start at -11 and then I go up 2 to -9. So I have 3 times x is less than or equal to -9. If I want to undo multiplying by 3, I need to divide both sides by 3. So multiplying by 3 and dividing by 3, those undo each other. And then I'm just left with x. I can bring down my inequality sign. I don't need to change it because I just divided by a positive number, not a negative. And then -9 divided by a positive 3 is -3. So you only flip the sign if you're multiplying or dividing by a negative number. We divided by a positive 3, so we don't need to flip it. We have x is less than or equal to -3, so if we go over to our number line, -3 will go right in the middle. And if I want to go up, I need to go up to -2 and then -1 as we go to the right. If I want to go down, I need to go down to -4 and then down to -5. My inequality is x is less than or equal to, so it has to be a closed dot because it can be equal to. And then it's less than or equal to. So less than means we're going to the right, less than or equal to, or just less, or sorry, excuse me, the left, because we want to cover all of the numbers that are smaller than -3. And the more left we go on the number line, the smaller our numbers get. And then for example 3, we have 5x minus 6 is greater than or equal to 3x plus 4. So now we have variables on two different sides of the equal sign. So anytime we have variables on two different sides of the equal sign, our first priority is to try to get them together on one side. And we can't just combine them, like just move them over. What we have to do is we have to try to cancel out the x's on one side using inverse operations. So you can either subtract 5x from the left side, or we can subtract 3x from the right side. So I'm going to subtract 3x from the right side, and then whatever I do to the right side of the inequality, I need to do to the other side also. So if I subtracted 3x here, I need to subtract it on the left, and I'm going to do it underneath the 5x, because those are like terms and we'll be able to combine them. So 5x minus 3x is 2x. I'm going to bring down that minus 6. And then the inequality symbol comes down. 3x minus 3x, that cancels out. And then I'll bring down that plus 4 or positive 4. So now my x's are all on one side of the equal sign. So now I need to move everything away from that x. So I have 2 being multiplied by x, I have 6 being subtracted from it. So I'm going to undo that subtraction first. I'm going to move it over. So negative 6 and positive 6, those undo each other. You can bring down the 2x, bring down the inequality symbol, don't need to flip it because we just added a number. And then 4 plus 6 is 10. So now we have 2 times x is greater than or equal to 10. If I want to undo multiplying by 2, I can divide both sides by 2. So multiplying by 2 and dividing by 2, those undo each other. On the left side of the inequality, we're just left with x. I just divided by a positive number, so I don't need to flip my sign. It's going to stay facing that same direction, so x is greater than or equal to. And then 10 divided by 2 is 5. So x is greater than or equal to 5. So 5 goes in the middle of our number line. And then 6, 7 as we go to the right. Down to 4, and then down to 3. So it's x is greater than or equal to, so since it has that or equal to part, it needs to be a closed dot over 5. And then anytime we're looking at greater than or equal to, our arrow needs to point to the right, because we want to cover all of the numbers that are greater than or larger than 5. So like 6, 7, 8, all the way up to as high as you want to go. Example 4 is 6x minus 4 is greater than 2 times 3x plus 5. So we have variables on two different sides of the equal sign. We definitely want to get them inequality. We definitely want to get them together, but we can't yet because this right side is not simplified. The left side is. I can't combine the 6x minus 4, so I'm just going to drop that down. And then is greater than. On the right side, I can distribute this 2. So 2 times 3x is 6x. And then 2 times 5, or positive 5, would be plus 10. So we have 6x minus 4 is greater than 6x plus 10. So I want to combine my variables onto one side. I have to do so with inverse operations. So this is a positive 6x. So I'm going to subtract, and this is a positive 6x also. So I'm going to subtract 6x from both sides here. If I do it on this side, I need to do it to this side, so minus 6x and minus 6x. So 6x minus 6x cancels out, that's just 0. You can bring down the minus, or the negative 4. You can bring down the inequality symbol. And then 6x minus 6x cancels out again. You can bring down the positive 10. So we ended up with negative 4 is greater than positive 10. So because negative 4 can never be greater than positive 10, it's always smaller. Definitely a negative is always smaller than a positive. We can stop here and we can write no solution. So you always have to check. If you end up with something that looks like this, it's not necessarily no solution, but if this is false, it's not true, then it is no solution. And then number 5, 2 times 2x minus 3 is less than or equal to 9 plus 4x. So 5 is similar to 4 in that we need to distribute on the left side first before we can try to move all of our variables to one side. So I'll distribute the 2. So 2 times 2x is 4x. And then 2 times negative 3 is going to be negative 6. Bring down my inequality symbol as less than or equal to, and then I can bring down that 9 plus 4x. And then I have a positive 4x here and a positive 4x here, so I'm going to subtract 4x from the right side and then also from the left side. So 4x minus 4x, that cancels out. I can bring down that negative 6 is less than or equal to, and I can bring down my 9, and then 4x minus 4x also cancels out. So I'm left with negative 6 is less than or equal to 9, and that's always true. That negative 6 will always be less than 9. So if it's always true, if it's a true statement, then your answer is all real numbers. And that means that any or x can be any real number, and that would still make this a true statement. So there's nothing to graph for 4 and 5, but just know that if your x's cancel out, you have to just pay close attention if the inequality is true or false before you decide if it's no solution or all real numbers.